Welcome to the second episode of the Bomberman game development series in TypeScript. I had a few requests of what people wanted to hear, so I'm gonna try and follow those. First of all, I'm gonna try and speak up, because apparently my keyboard is louder than my actual voice. So gonna try to keep this video a bit shorter as well. I'm hoping to keep it to about 30 minutes. If that doesn't happen, then well, I tried. And as a third, I'm going to show a preview of what we're going to build this tutorial. So I'm going to trust that my future self is going to just put something on the screen right now. Exactly, that's what we're going to build. Now, I added in a few sprites, which we didn't have last time. Last time we only had player F in the backend. And now I added player B, player R, which are basically just front, back, right. No, not an issue. Okay, I'll put these in the description as well, so you can download them. Well, they're already in the description of the last video, but I'll put them in again, so you can download them if you don't have them. They're literally just, if you have the folder, in the zip that you can download from the website I linked, you can just go to Bomberman, front, first image, back, first image, and the same for right. Okay, let's go to our client. Last time we left off here. So what I'm also going to do is I'm going to create branches for every episode. So I'll make, oh my goodness, there we go, 7 times the charm. Check out the episode 2. Okay, and we'll run again. And then let me open my browser. And that's pretty much exactly what we had. I could use it, I was just moving along. Nothing really special about it. Okay, so one of the things I noticed right after I closed down the video of the last episode was that there was still quite a bit of inefficiencies. For example, when we create a game in our bootstrap file, right? Then the issue is that we pass a context, width and height. I'm not a fan. I think we should just start a game by passing the canvas element, and the game should do the rest. So we'll change that. Instead of this, we're going to get a constructor that will just get a canvas element, HTML canvas element, and then our context will be canvas element get context 2D, canvas element width, and canvas element height. Now, one of the other things is we use context, width, and height, which are things that, like, we kind of want everything in our app to have access to. And we have to send it along every time, which is not great because, like, it's just too repetitive in my opinion. So we'll make a type for that, which is the first type we're actually making. We're going to call it game data. Our context, which is canvas rendering context 2D, screen width, and screen height. And then instead of these, we're just going to take have game data. Game data equals we'll remove the this, and we'll change the equal sign to a colon, and it should be screen width, screen height. By the way, if you don't see me typing, then just look at the bottom. That's probably where I will be typing a regis query to replace with Vim. Okay. A few changes we have to make. This width will become this game data.width. Same with height. Screen height. Right. just hide, same with width, screen width. And our map will take this.context. We're going to just pass this with game data. And in our map, in our render function, we'll take that. But we still only need the context, so import it please, thank you. There we go. And then when rendering here, we'll just say this.game data context. And now that's already a bit cleaner. So we don't have that data anymore. Okay, another issue that we still have. Oh, yeah, actually. Let's save our canvas element. And we'll also change our player, because currently we have this char image, char x, char y, and then we render it here. Like, if you have to prefix all these things all the time, then it's probably because you're missing a class. So we're missing a class, which is the player or character, however you want to call it. And this one will have all these things, but will just be called xPos, y position, and image. Take a render function, which will take game data, and our delta. We'll also add a setup, which will be asynchronous. Doesn't really need to take anything. We need our char image here. This our image equals image util. And then we'll take these out. We only need our context at the moment. Oh my goodness. There we go. And this is our image. This is our xPos, yPos, and we need width and height as well. We'll get there. We'll set these manually. And now in our game, we can actually just add a player. After we exported it. There we go. We'll set it up. And we'll await this.player.setup. And then here we'll say this.player.render, the game data and delta. That should render it. There we go. And our player is still being rendered, which is great. Now I kind of want to take these things, put them in a different section. Still has to be asynchronous. And we'll wait till that's set up. Yeah, just makes it a bit clearer, really, where we have to add this kind of thing, these kind of things. Okay, now that we have that, we have our player class. Let's look into movement, getting our player to move around. So there are a few ways to do this, but overall, I kind of prefer to keep a list of all keys that are currently down and currently up, because it just makes it a bit easier than to actually have to add an event listener everywhere. And it solves quite a bit of problems that you'll get down the line. So I'm just gonna do that. So now player will make key states, which will be an object where the key is a string. It's also called the key of the object, but it's the actual key that's pressed. And then we'll have a boolean. Initialize that. And then not here, but in our setup, we'll say document.event listener key down. First, we'll have to prevent the default, because otherwise browsers like Firefox will just start searching, like the search option, Control F. And then a second, we'll say key states e.key equals true, and in this case, in the other case, down, up, false. There we go. And now we'll just keep an object with all the possible key states, meaning that we can just say if these are key states D, then, which means if it's true, or it can also just if it's false or undefined or any other false value in JavaScript, you can also just say if true. No, it's fine. It's fine like this, and then we'll just move the player along. Plus equals 100, and now we're very fast. Times delta, and now we can move the player along, which is great, which is a very, very great start. Now obviously this really doesn't belong in the player class, so we'll put that in a different class. Keyboard listener, actually we'll make keyListener, maybe. keyListener, which will have key states, and it will have these. I'm gonna make it a setup function as well, and the reason why I make it a setup function is because it talks to the document. I don't want to just talk to the document on object creation. I kind of want to be able to control when that happens. So, and I will have a few function. We'll get is key down, key name, return these are key states. Okay, and then we'll have is any key down, which is also very useful. Key string array, so we can pass a string of keys, and we'll check whether any of the keys are down. So we'll say keys.sum key this.is key down key. Basically what sum does is any of testing on this array, right? Any of the values in this array, does it return true? If so, skip the rest, return true. If it doesn't return, if not any of these functions return true, then we'll just return false. Basic explanation, you can check the internet if you want a further explanation. It's a very useful function, to be honest. Comment this out for a second. Okay, so that's our key listener. We'll initiate that in our game. And we're actually going to add that to game data because it's one of those things that everything needs, well, everything can need. And I don't need commas here. Okay. Key listener, new key listener. And in our setup, we'll run this game data the key listener setup. Can't forget that. And okay, then we should have access to it in our player by just getting the key listener. And then instead of just taking D, we'll say key listener is key down D. I will also add arrow right to be able to use arrow keys. There we go. arrow right works and D works as well. So we'll do that for all 4 keys. Or 4. Also, one thing, we're going to add support for AZERTY people keyboards, because that's what I have. Basically, the only real difference that you have to care about is the Q, the A are reversed in position, and the W and the Z are reversed. So meaning we have to check Q and A in this case. Arrow left and can't forget that. Can't forget this. And D will be now Z. No, let's do S first, and then do Z or W. Arrow up, down. Oh, don't know what I did there. Fat fingering, down and up. This will be Y, and when we go down we're adding to Y position, and when we go up we're removing from Y position, because when using the canvas the 0.0 position is at the top left. Let me think. Okay, looks good. There we go. We can move. One more thing I'm looking to do. I want to make a speed. Let's actually add it to, set it to 150. And then use that speed here. And as you can see, it works. Now we're moving around, and our player can actually move around. Okay, great. We forgot to add our width and height. The original image is the same width and height. That's why we didn't know. I didn't notice it. But you can see now that if we have a different width and height, it will just scale down. Okay. One more thing we want to do. Yeah, we're currently just adding to our position. I'm not a big fan of that. I like to use velocity. So our velocity is basically how fast we're moving in a direction. Oh. So whenever we start our render, we're going to set our velocity to 0, which will probably eventually change, because we don't want this player to like stop abruptly. We want to have like a really small sliding time, if you know what I mean. And instead of setting our position directly, we'll say this we'll set the velocity to the value that we're adding or subtracting. Subtracting or subtracting. I'm not sure actually. Whatever. Velocity y and velocity y to the minus of this speed times delta. I know I can just say minus this speed times delta, but this makes it a bit more explicit, easier to read. And then at the end, we'll say this is position x plus equals velocity x, and this is y plus this is velocity y. And the reason why you do this is because it kind of it separates the actual key binding with with movement, let's just say. And on top of that, it also makes it much easier to like gradually increase your speed or gradually decrease your speed. Okay, so we have our velocity. Now we should still be able to move. There we go. And now I kind of want to make it so that we can move in all directions, right? So currently we can also only, like our our sprite will always look forward. We kind of want it to look in the direction we're going. So that's why we have these two new sprites, which we're going to load in, and we're going to make images for front, back, right. This one's front, back, right. Okay, and a big issue that we immediately see, I suppose you see it as well, we don't have left. And that's an issue because we don't have a left sprite. But we don't really need a left sprite because we have a right sprite, and the left sprite is basically exactly the same, just the opposite direction, right? It just flipped. So that's what we're going to do exactly. The issue is, it's quite annoying to flip an image. Like, in Canvas it's not too hard, but you'll need to save the context, scale it negatively, and a few other operations. So what we're going to do is we're going to put the rendering of one of those images in a different class, and then that class is also going to get a flipped variable. And if we set that flip variable, it's going to handle the whole flipping for us, so we don't have to really care about that in the player class, and we can just render our sprite and not have to care about how to actually render our sprite, which is always a good thing, to abstract the rendering of the game away from the actual logic of the game. We'll have a sprite. We have our sprite, which will have an image. And we'll have a flipped state on the x-axis. We're not going to flip on the y-axis just yet, but we can always change our mind. Oh, okay. We're going to get an image from the constructor. We're also going to get the flipped state. But what I like to do in a case like this is instead of just getting it as a parameter, I like to use an object. And I'll show you in a second, but it just makes it way more explicit, and it makes it way more obvious what you're actually doing. And I find this to be like a best practice in most of JavaScript. So both backend, frontend, everywhere basically. In TypeScript, it's a bit different though, how you set one of those things. So basically we have to set define three curly braces. The first one is the normal JavaScript one that you generally use. The second one is the TypeScript definition of the object. And the third one is what we're setting the default value to be. So we would say flipped x no worries. Then we'll say flipped x is a boolean, and we'll also set flipped x to false by default. For some reason it's not correct. One sec, right? Flipped x is correct. We'll set the value of flipped x as a boolean. We'll initialize that with one of those, meaning that it has to be empty. Or we can just say flipped x true as our initializer, and then we don't have to set it like that, which is not what we want. We set it like this, and then we give a default here. And the difference between the two is this one only gets used when there isn't a single value. Now there's only one now, so if that one's not given, then there's none. But for example, you have two possible settings, flipped x and flipped y, let's just say, and you only pass flipped x, then the default value passed here will not be used. So that's why you need to pass it here instead of here. And that's why we put the question mark to say that, like, if this one's used, then we don't have to pass flipped x. Like, it's an optional parameter. Okay, design image equals image. I hope that was clear. I will have a render function, which will take a few parameters. It will take the game data. It will take x position, y position, take the width and the height. Okay, and then it will just use the context. Say context of draw image. This is our image. X, y. Okay. Now for flipping, if it's flipped, if we want to flip, then we basically have to say context.save. We will save the current state of the context. And then after we flipped, we'll say context.restore. So we'll go back to the save point, right? Then context.scale. And we're going to scale on our x-axis with a negative amount, which will basically flip the it will basically flip the flip the context around the 0, 0 axis, y-axis. So another issue that we have is that our x position is not correct anymore because the canvas is flipped. So we'll have to use a negative x position. So in this case, we'll say rendered equals minus x. Another issue is that we can't just use minus x, because usually our 0, 0 point is at the top left. But when we flip the context, it's at the top right. So our image also has its 0, 0 point of the image at the top right instead of the top left. So we have to add the width. Just to add that, and it will be correctly positioned. That's all, and that should work. So instead of using image elements, we'll use sprites. And we'll also take a left sprite. So we need to load these images. Forward, backward, and we're going to just copy paste for right. Okay, then this dot image f. Oh, let's rename image here to sprite as well, as to not be confused. Just to not be confused. Sprite f equals a new sprite. Image f. F will be b. Sometimes just forget how to use Vim, apparently. And on this one, f will be left. And we have to pass in image right, but we'll have to pass in flipped true. And as you can see here, it's like, that's why I use that object, because otherwise you'd have true like this. And if someone was reading your code that didn't know what exactly the second parameter was, then they just have no idea, and they'd have to look into the sprite to actually see what's happening. So that's why this is much cleaner and much better, in my opinion, at least. Okay, so now we have our sprites. Let's make a small function to get the right sprite. Get moving sprite, which will return if this dot velocity x is bigger than 0. 1 sec, then it will return right. If it's smaller than 0, it's left. If y is smaller than 0, it will be show the back because it will be going up. And otherwise, we'll just show sprite front, meaning if we're not moving and all velocity is 0, that will just show sprite f, basically. And then in here we can say this is get moving sprite render instead of context we have to get the game data. We'll still okay. Render game data. X is X position, Y position, width is width, and height is height. Okay, so now we're printing our sprite in the right direction. Well, it should be at least. And as we can see, it is perfect. Like even our flipped sprite still works. We can move around freely, and this is probably what you saw at the beginning of the video. Let's hope it was. Let's see, we should do some more cleaning up. First of all, let's make our sprites into an object where we take direction as the key and sprite as the value. By the way, this between those brackets is the type of the key of an object in TypeScript, if you didn't know. I thought I'd just throw in some TypeScript tips here and there, could be useful. And then this is sprites equals forward new sprite image f backward right and left image b image r image r and I flipped as well. And in the bottom here we'll say this of sprites forward, oh, no, this was right, sprites left, sprites backward, and sprites forward. I could put an S after that, but can't really be arsed at the moment. So these are gone, much cleaner. Also, we're loading these images and we're waiting for the image to load every time. We kind of want to load them all at the same time, don't we? That seems like a better idea to do that. So let's do that. Okay, so we'll put them in an array. Oh, shit. Regain control. Image promises equals array. Take these things away. Then let's say const image f, image b, image r equals await promise for all image promises, which basically means wait for all the promises in this array. When they've all finished, they can just happen at the same time. When they've all finished, we'll just get the results and put them in the same order as this array. So we'll just return an array of results, which makes it a bit cleaner already. Yeah, that looks all right then. Obviously, there are quite a few things that we still have to do, quite a few things to clean up, but that's all right. Next week, I definitely want to set up sprite sheets, get sprite sheets working properly, and that way we don't have to load all these images, and we can just load a single image from the server for our player, which makes it much more efficient, obviously. And our movement will probably be extracted as well. So we'll see how that goes. Thanks for watching. have a good one, and I do hope you enjoyed. Bye.